this video, we will talk about how to access knowledge stored in graph databases using Fantasia. Graph databases are a powerful and flexible way of representing data that has been gaining popularity in the last years for its many applications. Fantasia allows to easily access Neo4j, an open-source graph database in UE4. This is an important feature for embodied conversational agents because it supports complex reasoning and helps building characters that appear to be more intelligent. First of all, let's briefly summarize what a graph is. A graph is composed of nodes and relationships between nodes. A node in general represents a domain element, like a person, a book, a movie, etc. Relationships between nodes describe how objects described by nodes are related to one another. For example, a person wrote a book or a movie is inspired by a book. Representing knowledge in this way helps keeping things clear without having to deal with specific data structures like tables, for example, so you can concentrate on the semantics of your domain. After you download Neo4j Desktop from the Neo4j website, I'll put a link in the description, you get this interface. In here, you can create new projects and new databases inside new projects. In this case, we are going to create a local database. So add local DBMS, and let's call it playground. Choose a password. I'll use playground again, and then create the database. After it finishes, you can launch the database by clicking on Start. And you can run the interface to access Neo4j, which is called Neo4j Browser, by clicking on Open here. In the beginning, the database is empty, as you can see by checking here. So we need to actually put data inside our database. For this tutorial, we will use the example data that Neo4j uses to present its functionalities. So click on Play Guide here, and the tutorial will start. You can move around the instructions here by using the arrows, and if you follow everything till the end, you should get a basic understanding of how Neo4j works. To populate our database, click on this first query, and then run it. And as you can see, the first graph database is populated now. Neo4j uses the movies domain to present its basic functionalities. So as you can see, we have nodes representing persons and movies connected by relationships. We will be querying this data inside Unreal using Fantasia. So first of all, we need to know how to query Neo4j in order to extract this information. Let's continue with the tutorial. I'll close this window. Here you get some first examples of Neo4j queries using a language that is called Cypher that allows you to extract information from the database. So for example, from the first query, you can extract the node whose name is Tom Hanks. So here's the node, Tom Hanks. You can see down here that the properties of these nodes are shown by Neo4j. So this node, Tom Hanks, has a property, name, that contains Tom Hanks, and a born property containing the year in which Tom Hanks was born. You can do much more with Neo4j. So for example, you can extract movies that were released in the 90s as a list here it is giving you back a list because the query returns a property rather than a node. This is an important difference. We can also do pattern matching on the graph structures, for example here, by finding co-actors of Tom Hanks, so people who acted in the same movies Tom Hanks was in. So let's click on the query, and we want to match a node that we will refer to as Tom of type person with a property name with a value Tom Hanks. This node should be linked to another node that we will refer to as M by a relationship of type acted in. And we want to find the other nodes we will refer to as co-actors linked to the same movies where Tom Hanks acted in by another relationship acted in. And we want to return a list of names for these actors. So we're asking for another list. Let's run this query. And here we get a list of people who acted with Tom Hanks. So now let's jump into Unreal and see how we can query the database from inside blueprints in order to retrieve data that we may be interested in to sustain a conversation. First of all, let's create a blueprint class. It's sufficient to have an actor in this case, so I'll create an actor and I'll call this JSON. I will instantiate JSON in the world. We don't need to have an actual body right now. And I will open the blueprints editor. In the editor, I'll switch to the event graph here. And I will add a Neo4j component. Let's drag the component in here, compile the blueprint. Everything is okay now. Let's set up the component. For the endpoint, since the database is running on my computer, I'll just put localhost. The default port Neo4j listens to is 7474. We left the default user Neo4j and the password is playground. Here. So what we want to do is query the database when the game starts. So I'll drag a new node out of Neo4j. I'll look for query and I'll choose submit query. Here you have all the parameters that you need to query Neo4j. Here's a field where you put the query. You can choose different types of modes for your query. Let's just focus on single request for now, and let's not talk about transactions. We will talk about parameters during these tutorials when we will link the Neo4j queries to natural language understanding. So for now, what we do is to connect this event to the submit query. Let's go back to Neo4j and copy the query from before so that we get the list of co-actors of Tom Hanks. And let's paste the query here. I'll just modify this query a little bit so that the column that I get as an answer in table format for this query does not have a name coactors.name, but simply coactors. So I'll rename the column using the as keyword so that the column is called coactors. Okay, so this sends the query to Neo4j. We now need to retrieve the results. Select the component and click on the incoming response event. This creates a new event that fires when the component receives the answer to our query from Neo4j. I'll split the structure pin so that we can see the different parts the answer is composed of. Now, the format of the result is in table format too. So we have an array of rows, and each row is an array of cells. This totally maps what happens here in Neo4j. So what we're gonna get here is an array of rows, and each row will contain one cell corresponding to the name of the column. That is why I renamed it, so that it's easier to access. So if we just want to print the results from this first query, what we need to do is cycle over the rows in the table that we're getting. So we will use a for each loop. And for each of these rows, we want to get a column the cells of the row. And from these cells are a map structure, mapping strings onto cell objects. And we know that the name of the column that we're interested in is coactors. So I'll go find the coactors column among the cells. Now that we do have the correct cell, we need to convert the cell in the correct format. There are different formats Neo4j can retrieve results. So there is the simple string. It can give you back a node. It can give you back lists and so on. In this case, we need to use a simple cell value. So we do this cast. And from a simple cell value, we can get the actual value as a string and print it. I'll just put 10 seconds of duration on screen so that you can read it. Here, let's compile it. So, summarizing, when I start the game, the component will send the query to Neo4j. An event gets fired when the answer is ready. This loop cycles over rows in the table that results from the query. From each one of these rows, I get the cell corresponding to the column coactors. I convert the result to a simple result cell, and I get its value to print. Let's see if it works. I hit play, and there it goes. Here we have the list of coactors of Tom Hanks coming from Neo4j in the Unreal Engine 4. This concludes our first tutorial about how to build an embodied conversational agent in UE4 using Fantasia. In the next tutorials, I will show you how to connect the knowledge that is hosted by Neo4j using natural language understanding functions with Microsoft Azure.